Today we're starting section 1.3 and we're going to be talking about basically more basics on the functions and their graphs like we have the other day. So first thing we're going to discuss is the interval of increasing, decreasing, and constant. And again, this is something we went over last year. We just need to kind of refresh our memory. So the notation I used to use was an upward arrow, downward arrow, and a C. So for increasing, it essentially means the interval has to have a positive slope. And when you write increasing, you use interval notation, except you don't use the equal to. You don't say this is where it's equal to or not equal to. You just always use parentheses. So always use parentheses for the interval notation. Decreasing means this is where the interval has a negative slope. And the C represents where it is constant. Which means the slope is 0. So again, it's always like interval notation, except you use parentheses because you're not telling me like, oh, this one specific value is included. You're just saying it's simply increasing and decreasing here. So here is a picture. Again, we're going to practice domain and range because that's a skill that we need to get better at. So domain and range is left to right. So notice left to right, every single value is hit. So my domain, let me change this marker, would be negative infinity to infinity, both parentheses on these. Range, bottom to top. Notice there is no ending points either way, so the range is negative infinity to infinity. So now we got to go through, and when you're determining increasing or decreasing, we always read this left to right, just as if we were reading a book. So, as I'm traveling from the left going to the right, here I have a negative slope. Notice it changes directions right here. So after that point, once I cross over, now I have a positive slope. Again, it's going to change directions right there, and after that, again, I have a negative slope. Nowhere on this is constant, so I could put the null set through there because it's not constant anywhere. So for my first increasing interval, so notice it's increasing from here to here. So the x values that would match it are from 0 to 2. And that's something I should have put on the last slide, that you're always using your x value. So it's essentially you're breaking down the domain. My decreasing starts from over here, the left, and it stops at 0. So the first interval of decreasing is from negative infinity to 0. And then it picks up here at 2, and it goes forever. So from 2 to infinity, it will continue to decrease. So notice these three things, if I piece them together, I would hit everywhere from negative infinity to infinity. So that's a way you can kind of check yourself. So let's try another one. So here's our next picture. So again, domain is left to right. So furthest from the left, going to the right, every single value is going to be hit in terms of my x values. So my domain is negative infinity to infinity. My range, bottom to top, is here's the bottom to the top, going up. So my range starts at -1, and it will continue up to infinity forever. Again, this side over here, this piece is going to keep going up. This piece is going to remain constant at the value of 2. So yes, 2 is hit several infinity times, and it's hit over there. But the rest of that is going to continue to travel up. So every y value will be hit bigger than -1. So now we're going to work left to right and dissect our graph. So working left to right, this first piece is what we would call constant. It has no slope. And it changes directions right about here. And now the second piece has a positive slope. So it's increasing, so I'm looking at my x values, it's increasing from 0 to infinity. It's decreasing nowhere, and it's constant, coming from negative infinity to 0. And again, notice we're not putting, we don't use brackets, you only use parentheses for decreasing and constant. Last thing we need to discuss is relative maxima and minima. So your max and min would be your highest and lowest point. So your relative highest and lowest point. So we're going to go back to those same pictures that we just did and discuss what the relative max and min are for each one of those pictures. So going back a slide, so here we'll write down at the bottom max and min. So the word relative implies it's relatively the highest one within that interval. So our relative max is going to be this location right here, because on this side, this dot right here has the same exact y value as this one, and all of these dots will continue to be higher. So the issue is that we could sit here all day and I could pick a value and you would be able to pick one that's higher, and we could keep going back and forth. So that's not the relative max. The relative max is one single point that is relatively higher than the rest. So this location right here would be our relative max. So our relative max is happening at 2, 3. Our relative min is going to be this location right here, again, because all of these are going to keep traveling to negative infinity, so every value you pick, you could pick someone lower and so on. So this is relatively the lowest spot. So our min would be at 0, 0. So on the next one, it asks for a relative max. So again, notice this is going to continue to travel, so we're going to kind of disregard that piece because that's not going to have a relative max. Now we're looking at this piece. But all of these pieces are at the same exact height. So again, there's infinite many of these maxes. There's no one specific relative max. So in terms of our max, we would say that there is no relative max. Now our relative min, we do have one point that's the lowest of them all. However, that point doesn't exist. It's not defined. So this dot right here is not defined. So the min we would say is 0, -1, but it's an undefined value. So technically it does not really exist. So that's all for today. We're going to pick up with this tomorrow and do some practice on dissecting our graphs.